Okay, there's this table at the very, very end of the book. In fact, it's really at the end. So these last 2 pages, I would recommend looking at. We've actually covered differentiation formulas. I think, I did that derivative blitz where we basically did all of these, except maybe 13 and 14, which I should probably talk about at some point, try to give you a reminder why those are true. There's sort of beautiful arguments for those. Then we went through all these indefinite integrals. So I kind of went through all these basic ones, right, in one of my videos. This was by parts. These are good. This was by substitution, number 7. Tan x equals sine x over cosine x, and let u equal cosine x, and that'll give you this result. Number 8 here is actually that weird integral. We did this with a equals, we did this by parts. That was that indirect by parts argument. Just a and b are constants here. So we did this example, e to the x sine x, right? So if you just set a and b equal to 1, then we get that. This one, number 9, is similar. 10, 11, and 12 are also similar, but I might do an example. Something like number 10, a video of that, just to show you. So 10, 11, 12 are all similar. And then 13, we did by parts. We did an example of this by parts. 14, we kind of did. We did the integral, I think, of t cubed e to the 3t, or e to the 2t, actually. So it's a similar idea. That was a multi-step by parts. So p of x could be anything here. P of x is just any polynomial. So anything with powers. And this formula, you could actually check this formula with a equals 2, here a equals 2, and p of, I guess it's a function of t, is t cubed. So you could compare what we did in that example to the answer here and see if you get the same answer, right? Here, p prime of t is 3t squared, p double prime of t is 6t, and p triple prime of t is 6. Interesting if we actually got the right answer there. Hopefully we did. So we've done an example like this, and you can generalize. This was a multi-step by parts, right? That was the idea. Right, like we used by parts to get this integral once, and then we used it again to get the next integral, which involved p double prime, second derivative of t cubed, which had a t in it, and so on. These 15 and 16 are similar. These are similar to 14. Now here's where we get some interesting stuff that's kind of different. I would like to do this one, like 17. This is also a by parts argument, actually similar to the weird one we did. I'll show an example of this, and then 18 will be similar. I'm not going to worry too much about these when the sine and cosine are on the bottom. Although I might do something like number 20 to show you where that comes from later. That's going to use a later idea. And then this one, I want to actually show you some examples. If it says this is a long explanation, but if m or n is odd, that's this first kind of couple sentences. I'm going to show you an example of this. And if they're both even and positive, then you can sort of go back up to these. You can convert everything. And so when I do the example number 17, it'll be kind of like this. And I'm not going to worry about negative power. So you could always make this more and more complicated. And then the last ones, 24 through 31, are kind of a new idea. There's a couple ideas that are called, one's called partial fractions. And the other is called trigonometric substitution. Both of which are nice, and we'll look at a little bit next week. So, the book says to use the table to answer questions, and that bothers me because where do these formulas come from? Like, we should be able to derive these formulas, any formulas we use. So that's my thought here, is just like, we would like to be able to derive most of these formulas. And I would will probably want you to do that rather than just quoting a table, to try to actually go through the process to finding the integral. Okay, so I'll do a bunch of these examples, or these ones I've started at least, in the next few videos. So I'll stop there.